Welcome to my YouTube channel. Today we are discussing very important questions. Let's start the question without delay. The first question is if 1 plus x to the power n equal c naught plus c1x plus c2x square plus cnxn, then prove that c naught cn plus c1 cn minus 1 plus cn c naught equal to n factorial over n factorial. We have to prove this. Yeah, okay. Now proving part. Let's see proving part, how to prove this. First of all, we have given 1 plus x to the power n equal c naught c1x c2x square cnxn. This is supposed by I. Again, writing the series in reverse order, then we get 1 plus x to the power n equal cnxn plus cn minus 1 x en minus 1 plus c3x3 c2x to the power 2 c1x plus c naught. This is supposed by second equation. Multiplying I and II, then we get 1 plus x to the power 2n equal, the product of these two same base power will be added, equal, right, in this c naught plus c1x plus c2x square plus cnxn times cnxn plus cn minus 1x n minus 1 plus c1x plus c naught. Then this is an identity. Yeah, this is an identity. So the coefficient of x to the power n on both sides must be equal. Therefore, that must be equal. Now, the coefficient of x to the power n on left side equal c to n comma n to n factorial by n factorial, and the coefficient of x to the power n on right side, right side equal, for this let's see, x to the power n, if we multiply this, let me use another color, then we can find this c naught and cn x to the power n it will be c naught cn plus, if you multiply these two, c1x cn minus x to the power n minus 1, this power 1 and this power minus 1 will be cancelled, so c1 cn minus 1, yeah, it will be c1 cn minus 1 x to the power n, here also x to the power n, plus finally in the last cn c naught x to the power n, yeah, here should be power n, yeah. Then the right coefficient and left coefficient we can equal. Therefore, from these two relation, this is the coefficient of x to the power n on the left side. This is coefficient of x to the power on the right side. So they are equal. Therefore, c naught cn x to the power. Sorry, is one missing here being we are writing the coefficient, not x to the power n. Okay. So cn plus, here is also c naught, so the coefficient only we can consider, then that's why cn c naught cn plus c1 cn minus 1 plus dot 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 cn c naught equal this one we can write 2n factorial over n factorial times n factorial, that will prove the given condition. Here is x to the power n, reminder, and here are the coefficient only. We should not write here x to the power n, because the coefficient of x to the power n is I have written here. Then from these two relation, the coefficient of x to the power on the left and coefficient of x to the power on the right, then equating them, the result we obtain. Now dear students, we have to move to the next question, very important question or interesting question. Number 2, expand 999 to the power 3 with the help of binomial theorem. Binomial theorem, very interesting question. Solution, dear students, here we have given 999 to the power cube. If you use calculator, 999 to the power 3, directly you will get the answer, but the condition is binomial theorem you have to use. That's why 999 is 1000 minus 1 to the power 3. If minus 1 is common, 1 minus 1000 to the power 3. So using binomial theorem, minus 1 minus x to the power n, like that, 1 minus c31 1000 plus c32 1000 square minus c33 1000 cube, yeah, n3, so there are 1 2 3 4 terms, and minus 1 times 1 minus, this will be 3000 plus this will be 3 after 1 2 3 4 5 6 zeros, this is 1 after 1 2 3 4 1 2 3 4 5 6 7 8 1 2 3 4 5 6 7 8 9 10 1 2 3 4 5 6 7 8 10 zeros, and the answer is 997002999 is the answer. So not the difficult question, but using binomial you have to track in this way and you will get the answer. Now the next third important question or additional question is number 3. If the coefficient of x in the expansion of x square plus k by x k by x to the power 5 is 270, then find the value of k. Solution. The the general term in the expansion of x square plus k by x to the power 5 is tr plus 1 equal c5r x square to the power 5 minus r k by x to the power r. Then this equal equal 5cr, then this k is k to the power r. Second I have written k to the power r. X to the power 2 times 5, 10 minus x to the power 10 minus 2r, and x to the power minus r, that is minus r. So it is 5cr k to the power r x to the power 10 minus 3r. For the coefficient of x, for the coefficient of x, we must have 10 minus 3r equal to 1. Therefore r equal 3 from solving from here. For the coefficient of x, we must have, for the coefficient of x, this should be 1. In the expansion it should be 1. Thus t3 plus 1, that is t4 equal 5c3 k to the power 3 times x. 3 times 3 is 9, 10 minus 1 is x only. However, by the question coefficient of x equal 270, then 270, then this is the coefficient. K to the power 3 is 5c3 equal 270. Yeah, k3 equal 270 divided by 5c3, we will get 27. k3 equal 27, therefore k equal to 3. Answer. That you can apply this rule 5 factorial. You know that I have not invested more time for that. So in this way you can solve this very important question. Let's put remaining 2 questions which are also important to us. Welcome to this class, dear students. Today we are discussing few more important questions. Without delay, let's start the question. The question 1 is, if the 3 consecutive coefficient, if the 3 consecutive coefficient in the expansion of 1 plus x to the power n be 165, 330, 462, then find n. Okay, then HSEB 2066, 2061, and in other examination also the questions were asked. Now the solution, dear students. Firstly, let the three consecutive terms be tr plus 1, tr plus 2, tr plus 3, then tr plus 1 equal cnr x to the power r, tr plus 2 equal cnr plus 1 x to the power r plus 1, and tr plus 3 equal cnr plus 2 x to the power r plus 2. Then if r plus 1 is cnr x to the power r, then r plus 2 is r plus 1 plus 1. That's why r will be r plus 1. The power is raising in the same way. R plus 3 means r plus 1 plus 2. That's why r plus 2 plus 1. That's why r is r plus 2. Then whose power is r plus 2. By the question, CNR equal 165, CNR plus 1 equal 330, and CNR plus 2 equal 462. We have supposed these are three cases, 1, 2, and 3. Now dividing second by first, dividing 2 by 1, equation 2 by 1, then CNR plus 1, this is 2, divide by CNR equal 330 over 165, or CNR is n factorial over n minus r plus 1 factorial times r plus 1 factorial whole over CNR is n factorial over n minus r factorial times r factorial equal 165 to the 330. After that, dear students, we can quote n factorial and n factorial, then 1 by this and this by this. That's why n minus r factorial times r factorial goes up, n minus r plus 1 factorial, r plus 1 factorial remains down. That's why, or from here, n minus r factorial times r factorial over, it goes off, it remains in down, n minus r minus 1, n minus r minus 1 factorial times r plus 1 factorial, r times 1 factorial. n equal to 2, or simply n minus r factorial is n minus r times n minus r minus 1 factorial over times r factorial over n minus r minus 1 factorial, and r plus 1 factorial is r plus 1 times r factorial. R plus 1 minus 1 plus and minus 1 can be cancelled, then one step less, that is r factorial. So we can cut this, equal to, or upper one is n minus r, lower one is r plus 1 equal to, or n minus r equal to r plus 2, then n minus 2r to the left minus 3r equal to 2. This is the equation 4. We have supposed this is the equation 4. Again, dividing equation 3 by equation 2, then cnr plus 2 over cnr plus 1 equal 462 over 330, or this is n factorial over n minus r minus 2 factorial. Directly I have done this now, and r plus 2 factorial times this. I have reciprocal this also, okay, because in first case I have already mentioned that, that's why it goes like this. Then here will be n factorial, then the denominator of the denominator goes off. Yeah, here will be n minus r minus 1 factorial times r plus 1 factorial equal 462 by 330. If we cancel, we will get 7 by 5. 7 by 5 in the lowest term. If we find the lowest term, will be 462 divided by 462 divided by 330 will be 7 by 5. Using calculator I obtain that. Then this is cancelled, or n minus r minus 1 factorial is n minus r minus 1 factorial is, here you can write this, n minus r minus 2 factorial, then r plus 2 factorial is r plus 2 times r plus 2 minus 1 is r plus 1 factorial. This is r plus 2 minus 1. 2 minus 1 will be 1. It will be 1 factorial. Similarly here, n minus r minus 1 times n minus r minus 2 factorial, 1 less, that's why it becomes 2 by 1. Then r plus 1 factorial, as it is r plus 1 factorial equal 7 by 5. Then we can cancel this, we can cancel this. So what we obtain, n minus r minus 1 n minus r minus 1 over r plus 2 equals 7 by 5, or by cross multiplication 5 times this is 5n minus 5r minus 5 equal 7r plus 14. Then by simplification of this, 5n is as it is minus 7r and 5r minus 12r equal 14 plus 5 is 19. This is equation 5. n minus 3r equal to is equation 4. 5n minus 12r equal to 19, that is equation 5. Now we have to solve them. Now solving equation and 4 and 5. The equation 4 is, let me rewrite this, n minus 3r equal to, and equation 5 is 5n minus 12r equal to 19. So we have to multiply equation 4 and subtract to 5. Yeah, now multiplying equation 4 by 5 and subtracting equation 5. This multiply by 4 and subtracting to this. Yeah, so what we get, 5n minus 5 3 sorry, equation this by, we can cancel this. Yeah, so equation 5n minus 15r equation 4 by 5, equation 4 by 4, not 5, it will be easier, n will be not. Okay, let me change this pattern. Multiply equation 4 by 4 and subtracting equation 5. So this will be 4n minus 12r equal 8. It will be 5n minus 12r equal to 19, and while subtracting sign will change, it will be plus, it will be minus. 4n minus 5n is minus n equal 8 minus 19 is minus 11, minus minus cut, therefore n equal to 11. If we remove n, then it will be difficult. Again we have to substitute, so we have to remove, or we have to cut that r terms. That's why we need to subtract by 4. Therefore n equal to 11 is the required answer. Question number second. Question number second is, if the four consecutive coefficient in the expansion of 1 plus x to the power n, in the expansion of 1 plus x to the power n be a1, a2, a3 and a4, then prove that a1 over a1 plus a2 plus a3 over a3 plus a4 equal to a2 over a2 plus a3. This is the question. If the four consecutive coefficients a1, a2, a3, a4 are the consecutive coefficient in the expansion of this, then we have to prove a1 by a1 plus a2 plus a3 by a3 plus a4 equal to a2 by a2 plus a3. Now proof, dear student. Firstly, let a1, a2, a3, a4 be the coefficient of their terms rth, r plus 1th, r plus 2th, and r plus 3rd term respectively in the expansion of 1 plus x to the power n. We have suppose coefficient of the terms, the a1, a2, a3, a4 be the coefficient of the terms, rth term the coefficient of this, r plus 1th term this, r plus 2th term this, r plus 3 term this, in the expansion this. Therefore, what is the value of a1? a1 means coefficient of rth term, coefficient of rth term equal cnr minus 1. I will write second and it will be clear, more clear. The a2 is r plus 1 term, coefficient of r plus 1th term, that is cnr. So r plus 1th term is cnr, then rth term is 1 less, that's why r minus 1, and r plus 2 will be 1 more because the standard is a2 or r plus 1th term. T r plus 1 equal cnr xr. We have written this, yeah. That's why in this case, if r plus 1 is the general term, r plus 1 term is there, here will be cnr x to the power r. So the coefficient is cnr. If this is tr only, tr can be written as tr minus 1 plus 1 to develop this from r plus 1 term. In this case, r minus 1 is r, so that it will be cn r minus 1. So it becomes this. It will not be, it is not confusing, yeah. So this is the note. Sorry students, so a3 equal coefficient of r plus 2th term, it is not confusing, cn r plus 1. Similarly, a4 equal coefficient of r plus 3rd term equal cn r plus 2. This is the first part. So we have to verify this result, or we have to prove that result. For that, dear students, now first condition is we have given a1 over a1 plus a2 equal. Let's find the result of this pattern. So a1 is what? cnr minus 1. a1 is what? cnr minus 1 plus cnr. Then we can do this in expanded form, that will be easier to understand. Okay, you can write, we can write this cn r minus 1 is n factorial over n minus r plus 1, because minus minus plus, factorial minus 1, r minus 1 factorial. Don't be confused about that. This is the first pattern, and over this is same, n factorial by n minus r plus 1 factorial times r minus 1 factorial plus cnr is n factorial by n minus r factorial times r factorial. First step we have done in this way. Let's move to the second step. So it can be written as n factorial, here n factorial over n minus r plus 1 factorial r minus 1 factorial all over, here will be equal sign. Here we can check n factorial is common, 1 over n minus r plus 1 factorial r minus 1 factorial plus 1 over n minus r factorial times r factorial. So we can cancel this, we can cancel that. So this term, this is 1 over, upper term is 1 over n minus r plus 1 factorial r minus 1 factorial over, here we can see n minus r plus 1 factorial, then the term will be n minus, but here n minus r factorial only, so I can write that this is 1 over n minus r plus 1 times 1 less means 1 cancel, n minus r factorial, right? Because that n minus r plus 1 minus 1 means 1 less means 1 cancel, n minus r factorial. So n minus r plus 1 times r minus n minus r factorial from here, then r minus 1 factorial, we can write only this in this term, plus here 1 over n minus factorial, n minus r factorial is common with this, so that we can write that is n minus r factorial times r factorial is what, r times r minus 1 factorial, because that will be common. So we find this term is common, this term is common, this with this, that's why it will be easier to simplify, that's why I have written this. So next step, dear students, let's see, 1 over n minus r plus 1 factorial r minus 1 factorial whole over, now we have to simplify by taking common. Yes, what is common now, we can write here n minus r plus 1, n minus r plus 1, these two are common and these two are remaining, and r n minus r factorial, this is from here I have taken, or we can write in another side also. So 1 2 3 4 terms, these two terms are common terms, these two terms are remaining term. So while comparing these two, 1 2 3 terms are, here is not r, plus here is these three terms n minus r plus 1 in the second one, so it can be cancelled. No, now we are in easy mode, dear student, one step easier. So I shifted here, I shifted here. So here is 1 over n minus r plus 1 factorial times r minus 1 factorial. Then it goes off times n minus r plus 1 times r times n minus r factorial times r minus 1 factorial. 1 2 3 terms goes off, and here is remaining n plus 1 only. Then the next step is, let's see, n minus r plus 1, n minus r plus 1 factorial. So we can change this. Yeah, so what can we write? One more step. What can we write there? Simply we can write, here you can write for cancellation, n minus r plus 1, n minus r plus 1 times n minus r factorial, one less, or the sum of these two product, or this product will be this. Yeah, n minus r plus 1 factorial. If you remember in that way, you can do that. N minus r plus 1 times n minus r plus 1 minus 1, that's why it is n minus r factorial. This term is written in that way. R minus 1 factorial, r minus 1 factorial, we can easily cancel. Yeah, so here is r minus 1 factorial. Here offer is n minus r plus 1 times n minus r factorial, r times r minus 1 factorial, so that this can be cancelled, this can be cancelled. What we obtain here, one another term n plus 1 also, this term. So we obtain upper is r, lower is n plus 1. So let's compare the final final solution of that pattern. What we are doing means, therefore a1 over a1 plus a2 equal r over n plus 1. This is supposed by 1. We obtain this result. Again, replacing r by r plus 1 in equation 1, then we get, so a1 is a1 plus 1, that is a2, and a2 plus a3 equal r is r plus 1 by n plus 1. This is pattern 2. Again, and replacing r by r plus 2, similarly we can replace r by r plus 2, then the pattern becomes a3 over a3 plus a4 equal r plus 2 over n plus 1. This relation is third relation. This relation is third relation. Finally, what we obtain? Now a1 plus a2 plus a3 plus a4 equal a1 plus a2 is what? R by n plus 1 plus r plus 2 by n plus 1 equal n plus 1 is common, r plus 2, 2r plus 2 by n plus 1 equal 2 common r plus 1 by n plus 1 equal r plus 1 by n plus 1 is what? R plus 1 by n plus 1 is this 2. The 3, this is 2 times, that is 2 times, so this is 2 times, now that is 2 times 2 times